We're going to be turning numbers into scientific notation. With scientific notation, it's going to take the form of a times 10 to the b. Now, a has to be a number in between 1 and 10, and b is an integer. This is the mathematical way of saying that something's an integer. It's an element in the set of integers. Now, an integer could be positive or negative. If it's positive, that means it's going to be a large number. If our b value is negative, that means it's going to be a small number. So looking at the first one, what we have is 67,800. This right here is a large number, and we need it to be between 1 and 10. So I'm going to put 6.78. That's a number in between 1 and 10. I'm going to times it by 10. And since it's a large number, I'm going to put a positive exponent. If I don't see a decimal, I know that it's at the end. So that would be 1, 2, 3, 4. So I'm going to put a positive 4. Looking at the next one, this is a small number. I need a number in between 1 and 10. So I'm going to put 5.12. That's a number in between 1 and 10. I'm going to put times 10. Since it's a small number, I know it's a negative exponent. I'm going to look at the decimal. 1, 2, 3, 4. So that means it's going to be negative 4. If we're looking at the next one, the first thing that we need to do is multiply it. How this multiplies is we take the 3 and the 5 and we multiply them to get 15. Then we're going to take the tens. Whenever we multiply, we add the exponents. So that's times 10 to the 10, because 4 plus 6 is 10. Now, this right here is not in scientific notation because 15 isn't between 1 and 10. We need it to be between 1 and 10, so I'm going to put 1.5. That means I'm taking the 15 and I'm moving it over 1. 15 would be considered a large number, so I'm adding 1 to the 10, so that gives me times 10 to the 11. Now our next one, we're going to take the 7 times the 9.1. If I take the 9.1 and I multiply it by 7, I get 7. 7 times 9 is 63. Since I have one decimal place, I have 63.7. So 63.7. Whenever we multiply, we add the exponents. 2 and negative 8 would be negative 6. Once again, this is not in scientific notation because this number right here is not in between 1 and 10. The number that would be in between 1 and 10 would be 6.37. Now, because this is a large number, we're going to add 1 to our exponent. So 1 plus negative 6 is negative 5. What I want you to do is pause the video for a second and see if you can do the next 4 on your own. So looking at the next one, we need a number in between 1 and 10. That would be 7. I'm moving the decimal over 1, 2, 3, 4. So I'm going to put times 10 to the 4. The problem is this is a small number. That means that I need a negative for the exponent, letting the person know that it's a small number. With the next one, this is a large number. I need a number in between 1 and 10. That would be 8.76. 8.76 is in between 1 and 10 times 10. Once again, this is a large number, so I know I have a positive exponent. If I don't see a decimal, I know that it's at the end. I have 1, 2, 3, 4, 5. So it's a positive 5. With the next one, I take 12 times 10. That gives me 120 times 10. Remember, I'm adding the exponents. Whenever I multiply, I add exponents, so that would be 7. Once again, this is not in scientific notation because it's not in between 1 and 10. In between 1 and 10 would be 1.2. Since it's a large number, I moved my decimal over twice, so I'm going to add 2. So that would be times 10 to the 9th. Now looking at the next one, 5 times 11 is 55. Times 10, I'm going to add the exponents. Negative 4 and 2 is negative 2. Once again, this is not in scientific notation because that's not in between 1 and 10. In between 1 and 10 would be 5.5. Since this is a large number, I'm adding 1 to the exponent. 1 plus negative 2 is negative 1. Now, this is writing a number in scientific notation. Now what we're going to do is we're going to write it in standard notation. This is how a number normally looks. So in our first case, it's in scientific notation, and we want it in standard notation. The negative exponent tells us it's a small number. That means if we're going to make a small number, we're moving the decimal over 3. 1, 2, 3. So I have point. Notice that I don't have numbers here, so I'm going to put zeros as placeholders. And then 722. And that would be my answer in standard notation. If we're looking at the next one, I see a positive 5. That tells me it's a large number. My decimal's right here. I'm going to move it over 5, making a large number. 1, 2, 3, 4, 5. I have 816, and then I'm going to have 3 zeros as placeholders. Looking at the next one, I'm going to multiply 0.6 times 0.6, which is 0.36. Remember, whenever I multiply, I add the exponents. So that would be 2 plus 5, which is 7. Since this is a positive 7, that means I have a large number. So I need to make a large number. So that means I'm moving this decimal over 7. 1, 2, and then I'm going to have 5 zeros. 1, 2, 3, 4, 5. So I have 3, 6, 1, 2, 3, 4, 5. So that would be 3.6 million. Looking at our next one, we do the same thing. I'm going to take the 4.2, I'm going to times it by 3. That gives me 6. That gives me 12. 1 decimal place. So I have 12.6. Remember, I add the exponents whenever I multiply. So it would be times 10 to the negative 3. What we need is something in standard notation. Negative means it's a small number. So what I'm going to do is I'm going to take my decimal and I'm going to make a small number. I'm moving it 3 spots. So I get 0.0126. What I want you to do is pause the video and try those next 4 on your own. So we have a number, and what we want to do is we want to put it in standard notation. This is a positive 4, meaning we want a large number. So I have the 5, 1, 2, and then I'm going to add 4 zeros to it. For the next one, I have a negative exponent. That means a small number. So I'm going to take my decimal, and I'm going to make a small number by moving it 2 spots. So I have 0.0789. For the next one, 4 times 0.7 is 2.8 times 10. Whenever we multiply, we add exponents. So that would be negative 3. Since it's a negative exponent, what I'm going to do is I'm going to make a small number. So I'm taking the decimal, I'm moving it over 3, and I get 0.0028. And for my last one, 8 times 9 is 72. I add the exponents. I need a number in standard notation. So if I don't see a decimal, I know that it's at the very end. Since it's a negative exponent, I know it's going to be a small number. So I'm moving it over to make a small number, and I get 0.72.